I'm having a look at how to integrate functions that are in a fraction form, where you've got a function over another function. Now, the only way we can do this is if that function on the top is the derivative of the one on the bottom or a factor of that. Then we're able to use the rule that it is ln of the function plus c. So first example we've got here is 20x over 10x squared plus 11. So the first thing I'm going to do is look at this 10x squared plus 11. What's its derivative? So the derivative of the 10x squared is going to be 20x. So that means what I've got on the top is a derivative of what's on the bottom, which means I can then go straight to my answer here of ln of 10x squared plus 11. And I'll be subbing in the values of -1 and 2 into that function. My other option when I see that is to do that on my calculator just graphically. So put those functions into the calculator and then use the integral function to be able to do that. So I've got the 10x squared plus 11, graphing that, and then putting in to the integral part I want between -1 and 2. That shades that in and I'll get my answer there. Same as if I had just subbed in those values into that equation there as well. Obviously check what marks are being allocated, which way you are looking to solve it. Is it a take active question or are you trying to show that your understanding of integrals? The second one, a little bit different because our derivative of the 5x squared is 10x. Now we don't have 10x on the top, we've got 5x. So what we've got is half of that. So what we can do is put a half out the front of the integral sign and then put the 10x on the top, and we now have the function, like the derivative on top of the original function format that we want. So that means that half there is going to go in front of the ln of 5x squared plus 11. And then we're just looking at that between 1 and 2. So again, you could just put that into your calculator, but in these type of questions, they're wanting you to show that understanding. So you're going to be subbing in the values into that equation there to then be able to find the integral of it.